Hi guys, thanks for tuning in to LastHumansTech. Today we're going to talk about file management, compression, permissions, and links. So first let's just look at the find command. Now you can use this without any other information at all. And what this is going to do is it's going to search for every single file on the whole system. If this is the very first time you've run this command, it could be a bit slow. It's going to go through every system, every file. But it's also adding it to a cache when it does this. So the next time you have to find a file, it'll be much faster. You can see here it just went through my entire system in about 1 second. That is because I ran this file previously, I ran this command previously, and it was all in cache. But it would take 10 times as long the first time you run it, so just be aware of that. It's good to run it every once in a while to just make sure everything is fresh in the cache. Now you can also do a find under root and use a name, a file name, but you have to use quotes in this case. So I'm going to go ahead and search for the Mark G anywhere I can find it. And you can see there aren't too many options, but it does find 3 or 4 sections where there is a directory called Mark G on this computer. Now another command you can use is locate. And let's do the same thing here, but you do not need quotes in this case. And here you will find a lot more information, every single area that has Mark G in the path. So this is a much more robust command. This is also a much faster command because locate uses a database to keep track of all its search. So let's clear the screen. So let's say you use locate. You would then use you could use update DB to refresh your database from time to time to make sure that it's responsive to all your newer files and your changed files. So that's all it does. You're updating the DB for locate. So remember those two connections. Locate uses the update DB. And just for reference, you will find the configuration file for that locate and update DB find under Etsy and the updatedb.conf file, CONF. And here you can see where you can prune various items from the search. It's a very simple configuration file, but you do want to remember those 3 items: locate, update DB, and db.conf under Etsy is your configuration file. And of course we have already looked at the where is and which. Let's just check that one more time to refresh. The where is will show you every spot that there is a gedit file or executable. And remember, if you want to know exactly which file is executing when you type the command, you just type the which command. See, it makes sense. Which file, which command. And you can again do this, and it will then prune those results a bit and only give you the path to the actual command that you were running. Now you do have a different type of command related to files here. This would be the command type, and this could tell you, it could give you some information about a file type that you're looking at. So let's say we want to look at the cat command itself. It's a hashed command and it tells you where it's located. You could type to look at the ls command, and it will tell you some information about that. So you can use the type command to learn the type of file that you were looking at. However, do note that the type command will not work on all types of files. Let's just look at this long file, for example, right in this directory. It will not work on some of these files, so you can use it more for commands and things like that. Alright, let's jump into creating some files and folders here. So we're located in my home directory right now. We're going to make a directory called work, and we are going to check that it exists. It's at the very back there, and we're going to cd into work. Now we're going to make a directory called customers, and we're going to make a directory called suppliers. And let's go ahead, and now you have two directories under here. Let's cd or change directory into the customers directory. Now you can see we're in the home, mark G, work, customers directory. Remember to touch an empty file. To create an empty file, you would use the touch command. So I'm going to just create an empty file in here, and let's see if this works. It hasn't been working for me recently, but just curious if this type will work. No, the type still won't work for that. Okay, that's interesting. Now we want to put some things into the customers list file. So we're going to echo and send it to the customer list. Now that put that line in there. Now we're going to echo another command, Cpio, and append so it does not overwrite the last human line above it. And we're going to also put that in the customer list. Now let us look at the customer list and just make sure it's there. We do have our two lines here, so far we're doing good. Let's show you the remove directory command real quick. Where are we? We're in customers. I'm going to back up a bit and clear the screen so we know where we're at. We're now in work. So we have two directories, right? Let's go ahead and see that those are D with the first letter of the permissions there. D means they're directories. So let's go ahead and remove directory suppliers. That worked, no problem. Let's do the same thing and see what happens with customers. It is not going to let us do that. That is really a safety precaution because it knows that there's a lot of information in that directory. Now you could do an rm-r customers, but we don't want to do that right now. And that would force it to go down recursively and delete everything in there. Let's change directory back into the customers directory. Check where we are. So we're now in the customers directory. We're going to copy, first let's see what we have in here. We're going to copy the customer list over to customer old. Now this is just creating a copy of the same file. It's not going to harm this original file in any way. So now you will have two files. You have customer list and customer old, both of which contain the same thing. Alright, let's go ahead and back up two directories. Clear the screen and see where we're at. So we now have our work directory, which still exists over there. What we are going to do is tar up. We're going to tar. This is a compression. It's kind of sealing it in a tar ball is what they call it. And we're going to use the C for compression option and verbose to show you what you're doing in file. And we're going to first type the name of the tar ball we want to create. And I'd call it something like this, and that's not right here. We're going to go here, and we're going to tar up, create a file called work.tar, and here we go. So what we did was we compressed up the work file, which is section 2, but the first option in that command has to be your file location, and it always helps to put your full path here, or else the system can get confused sometimes if you don't use your full paths and relative paths, things like that. So after the tar command ran, it shows you what it tarred up. Now if we ls, you can see you have a work and you have a work.tar. Let's go ahead and clear the screen and just view that. Now we're going to do an rm-r on the work folder. We're going to delete it. we're going to completely wipe it. Now this may be interactive and ask us for each step because that could be an alias on the RM command. And it is doing that, as we saw earlier. So I'm going to click yes, delete, 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 and delete. And just to show you the alias, why we had those confirmations even though we used an R, is we have this alias down here, which we saw in a few lessons ago, which is aliasing the interactive mode anytime you use RM. Now we could have used an F with this RM command, RM-RF, and it would have forced, and it could have skipped this step in those interactive sessions. So now you can see we only have a work.tar, and we lost all that information that was in work. Or did we? Let's try the opposite type of tar, which is to extract a tar. So instead of the C for compress, you use X for extract. And we're going to, first let me try it without a full path, and this should work, but I'm not positive. Okay, this did work because we are in the same directory. We did not need to type a full path to that. Now you can see it again tells you what it did on each of 4 of these lines. It shows you what it found and extracted. So let's do an ls now, and you can see that our work file is now back. So we go in there, and it looks like we have everything we needed. There it is. So we're going to back up 2 directories here, as we know. cd ... means back up a directory, / another ... means back up 2 directories, right? So now we're back up here. So that just showed you the tar command. Remember the tar CVF to compress up a tar ball, and tar XVF to extract it. C for compress, X for extract. Now let's look at the Cpio command, another compression utility. First, I'm going to show you what the find command will do for us on work. Remember, we are in our home directory. This should show all levels, and it does. So I wanted to show you that before we use this command. So we're going to use this command again, but we're going to pipe it. Remember, we're going to send the results of this command to another command. And this is going to be your Cpio. This is another compression. And you're going to use the OV option on the Cpio. O means create a Cpio archive. And V means, of course, verbose, which is common in almost every command. And it'll just give you more information. Now we want to redirect that command to make a new backup file. We'll call it work_back.cpio. You don't have to use the .cpio, but it's a good idea to make sure that you don't forget what type of file you made. Let's go ahead and see if this works. And it'll tell the files that it backed up. And let's do an ls and see if we got our file. All right, there we go. We have work back Cpio, and we have work.tar. Again, where are we? Let's go ahead and remove the work file with an F this time, which overrides the interactive I option if you use an F for force. So we forced it to just wipe that work directory. Let's clear it. Now we only have our Cpio and our tarball up there. Now let's do the reverse of the Cpio compression, and we'll uncompress it. We're using the I for extract this time. Remember, it was O for create and I for extract. It doesn't make much sense, but you just have to memorize these options. And we want to extract, and then as input, send in the file that we created. And looks like that's good. Remember, work folder was gone. Let's take a look now. Work folder is back. So we learned about the tar command with the C and the X options, and we learned about the Cpio commands with the O and the I options. Now you do have the DD option also, which is disk dump, which you would normally use something like a disk path if you wanted to dump a path to a different path here. And what you would use with this command is the if command, sort of like that, and the OF command to where you want to put it. And it's creating a copy of a disk image or dump, so to speak. Now this will not work on a directory here, but I just want to show you, just for test, what the kind of output it gives you, even though it won't work. So it can't do this because it's a directory. But this command will give you some details on how many records were in, how many records were out, and the total size and bytes of the operation that was handled. So the DD can be used to, say, back up a USB drive, a partition on your disk, something like that. It's a more robust, larger type backup system than the ones we looked at. Let's clear the screen here, and let's do an ls-l, and we want to look down here at the file sizes, and you can see the work back and the Cpio and the tar file. And what you want to see here is the tar file has pretty good compression, but the Cpio has twice the compression. You can see it's 10,000 kilobytes, and the tar file, and the Cpio file is 512 kilobytes. It's half the size. So the Cpio is a more powerful tool than the tar tool if you're looking for maximum compression. Now we'll continue with this information on the screen, and we're going to look at the gzip command. So we're going to, this is another compression command. You had tar, you had Cpio, now you have gzip. So we're just simply going to use a gzip command with the work.tar. And so we're going to kind of double compress. We're going to compress up a tar file, and let's see if this works. That did work. So let's go ahead and do another -L here, and you can see now that the tar file is gone, replaced by the gz. Remember, the tar file was 10,240 kilobytes. Now it's even smaller than the Cpio after we did that gz. So the gz is even more powerful still, and this allows you to tar and gz this file up. Now to uncompress the gz is a little bit easier. It's just gunzip. It makes a lot of sense. So we're going to go ahead and use the correct file name and say gunzip this time, gunzip. That worked again, and we should have our tar file back at the bottom. And there we go. So we've looked at the tar compression, the Cpio compression, and the gzip compression so far. Let's go ahead and remove our tar file now. star.tar. Remember, star is your wildcard. So there aren't any other tar files in here. It should just remove the one we want. So we removed it. Now we do not have that tar file. We just have the Cpio in there. So what I want to show you now is how to combine a tar and a gzip all in the same step. So instead of having to do it twice, right, you can do it once. So remember, we had our cvf command to tar up a file. We're going to throw in a z in here. And the Z stands for gzip. Sorry. So we're going to then create a file. Remember, first you have to put your file name that you want to create. So I'm going to call it work_back.tar.gz, just so we know it's tarred and gzipped. And then we're going to tell it what to tar up. And this did work. So let's go ahead and do an ls. And see, we created that tar gz all in one step with the z. Remember, the gzip is related to z. Now let's check the size of that tar.gz. And it's the same size as before, but it was done in one step instead of two, with just one simple extra option, which was adding the z to the tar command. So that's a little shortcut there. Tar and gzip it up at the same time, and you'll get even smaller than the Cpio file. Now the same thing goes through for the extraction of this file. So you normally use XVF, remember X for extract, but you're going to throw in the Z again because this is a gzip file actually. So you're going to tar XZVF, and we're going to take the file name and we're going to reverse that, and it always tells you what it did here. You can see that too. So let's clear the screen and look at it, and you can see it did not delete that GZ file, but we have the work file back now. So it did unzip it and put the work file back where it belonged. Alright, so let's check our file sizes now. So we have the full work file is about 4 megabyte, and our Cpio is 512 kilobyte, and our GZ file is 216. Let's look at the bzip now. I know there are so many compression files, it just gets confusing, but we have a bzip, and it's probably a bzip 2 on this particular machine. And we're going to bzip up this Cpio file. And that worked. So let's go ahead and look at this and see what it did. Now you can see the bzip brought the Cpio even smaller. Remember, it was 512 and it just cut it in half. So the bzip is yet another compression option that you can do. Now let's again do the opposite, which is bunzip 2. And just for a shortcut, we'll do something like that. So we're now doing the opposite. We bzipped it, now we're going to bunzip it, and we're hoping that that BZ2 extension goes away. It didn't tell us. Let's take a look. Alright, that worked. So now we've gone through tar, Cpio, gzip, and bzip. Alright, let's clear the screen here. Now remember how we used the Z option to add a gzip to our tar. In the same token, we can use the J option in the tar for bzip. So you have the Z for gzip and the J for bzip. And the other tar is the same, CVF, to compress up a tar file. And we're going to create the name of our file that we're creating, the tar. So I'm going to call it, I'll call it capital work underscore back dot tar dot bzip, so we know. And then you're going to tell it what you want to tar up. So now let's take a look at this. You can now see you have your bzip file also, and it is also about the same size, 200 kilobytes. And of course the same deal here. To reverse it is the extract with a J. Remember, J is bzip. And you can extract the same file, and let's just call it a star.bzip to save time. And it just extracted it, but you do still keep your bzip file because we have not deleted it. So it's basically overwriting the work file again and again. Now this can be very risky because if you have made changes in the work folder after you made all these backups, and then you decide I'm going to uncompress any of these files, it's going to overwrite this work folder without asking you anything. And you could lose changes in that work folder that you have made. So you have to be very careful when restoring any of these backups. You might use a different file name when you restore it to make sure you don't overwrite any new data that has been created. Alright, that's a lot of compression information for you to take in. So just keep studying it and practicing it and learn the differences in the tar, the Cpio, and the gzip and the bzip, and even the disk dump, DD. So let's talk about links for a minute. You have hard links and you have soft links. Very common question in any Unix interview or Linux interview. And hard links do not make a new inode, because a hard link is just like a second name pointing to the same file. It's not its own new file. So the only inode for a hard link is going to be on the file itself, and then you have two different aliases pointing to the same file. That is why a hard link does not create another extra inode. Now a soft link, or also a symbolic link, does have its own inode. It is like a shortcut, like a desktop shortcut in Windows, where it's going to point to a file, but it is an existing entity, so it does have an inode also. Let's just look at some links real quick. Let's probably go into user bin, which always has some good links, and we'll do an ls-l to get the full screen. And you can see two links on this page. These are soft links, and zsolem pointing to that file, and yp domain name pointing toward the host name. So those are what we call soft links, and these do exist in a lot of places in the system, especially with libraries and things like that. So let's clear the screen. Let's go ahead and make our own soft link and see if this works. So I'm going to use the ln command for link, -s for a symbolic link, and I'm just going to try. So what I'm doing here, you first give it the command that you're looking for, and then you type your alias second. So what I want to do is, when I type G, I want it to automatically open my gedit. So that command worked itself. Let's use the alias command, which actually will not work because that is not what we're talking about here. We're going to look at the user bin, and we're going to look for the gedit file. Let me scroll up a bit here. A little bit more. All the way up to the G. You can see right here, created today. G points to gedit. So that's my symbolic link. Let's see if that works. I'm just going to type G. What a silly letter. And if it works, it'll bring up the gedit command right there. So that's kind of like a shortcut to the gedit, and it will allow you just save a few keystrokes. And you can do this all over your machine if you like, for stuff that you use all the time, if you kind of memorize your own personal codes there. And you can have shortcuts to anything you want. Then I'll just do an rm-r user bin G, and I'm removing symbolic link just to leave my machine the way it was. Alright, let's talk about permissions next. Now, an important thing you want to memorize is read-only permissions would be 4, read-write would be 6, and read-write-execute would be 7. That's just the key main permissions that you hear about all the time. And also you'll see 644 permissions quite a bit. That is read-write and read and read. And what are we talking about here with permissions? Well, right here in this left column, of course. So you have your owner / user is the first column, your groups is the second column, and all others is the third column. You can see on this, for example, the owner has read, write, and execute, but anybody in the same group only has read and execute, and everybody else also has read and execute. So those are permissions, and let's look at how to set those up a bit. So let's go ahead and go back to the home directory, and we're going to create a test file. Now let's go ahead and look at its permissions. Under test file here, the default permissions are read, write, read, and read. So that would be, where was I here? That would be a 644, right? So you have a default UMask for this system, for the shell we're in now. And you can see here, it is 0022. So what this is going to tell you is that this is taking full permissions, and it's going to subtract these is your UMask, what it's going to subtract. And then it leaves you with this as the default permissions. Now you can change your UMask with the umask command and end up with a different starting permissions. But the umask is a safe way to make sure that you don't over permission your stuff here. Let's try a chmod 666 on the test file. And now let's just look at that file itself. So you can see that read-write is the 6, remember? So we just added read-write to every group, the first column, the second column, and the third column. Now there is one other way that you can add a permission. Instead of using the number scheme, you can use U, G, or O for user group other. So let's say I want to add executable to my user for this file. I can go user plus, and of course you can use minus to remove, X. So I want to change the modifications and add executable for the user file, for the user itself. And then we can do ls again, just look at this one file, and we now have an X here. So you can use the numbered format, or you can personalize different areas. You can even do a chmod UGX, user group other plus X. You can do that all in one shot, see? Not just your user. You can throw in anything you want on this side and anything you want on this side. So let's look one last time. And everything should now have executable. And that worked too. So that could be a little bit easier way to use it if you want to use the plus minus option rather than the numbered option for setting your permissions. Now you can see that the root owns these files. So we can change the owner in the group. We're going to look at that command real quick. So we're going to use the chown command. And we're going to say change the ownership to Mark G test file. And if we look at it, we've now changed that first section here to Mark G. Same thing with the group. We just changed the group to myself also. So here you can see Mark G, Mark G. Now let's go ahead and put this back real quick. Chown back to root. Change group back to root. Let's look at it real quick. Now you can do the chown command in one step also with a dot in between the user and the group. And that's a faster way. You don't have to use both commands. So let's take a look at this and see what it did. So that's another way to do it. You don't have to use the change group command if you don't want. You can do change ownership user.group with no spaces, and that's a shortcut there. Alright, let's clear the screen. We're going to talk about special permissions. You have the SUID, which is the set user ID bit, and the SGID, which is the set group ID bit. And what these special options do in permissions is they allow the user that executes the command to become the temporary owner. That's the user command. And anybody in the member of the group, if you're using the SGID sticky option, that would make anybody that launches that command become the temporary owner. Now the SUID is a number 4. I'm just typing this to show you. It's not a command. And the SGID is number 2. We'll talk about number 1 later. So how do you go ahead and set this? First, let's look at our test file. And we know the permissions are there. We're going to do a chmod, and you have another letter in front of those permissions. So you can see up above what we have is 777 right now. That's everything. Read, write, and execute. So let's say we want to set the user ID special bit, which is number 4, I said. The group special group ID is 2. So we do a 4. So you're basically setting a special bit before the other 3 columns that are standard. And let's go ahead and see what this did. You can see here, you now have an S here, which is special user ID. So anytime the user executes that, they're going to become the temporary owner of that file. Let's do the same thing here. And we're going to change that to a group SUID instead, an SGID for group. And we'll look at it again here. Now you can see that that S bit moved over to the group section instead. Now how do you remove all this? If you do not want that option on there anymore, you would set it to 0 to reset the file. Don't want to have that big mess there, sorry. And down here you can see the S's are now gone. Now one more thing I wanted to show you. You can have both the set user ID and the set group ID all in one shot if you like. You can have both at the same time. It's the same numbering scheme that you've done before. So we'd say chmod. Remember the set user ID is 4 and the set GID was 2. What's that equal? 4 plus 2 equals 6. So you could then do something like this. And this should now have both sections with an S in them. And there you go again. So you can do one or the other with a 4 or a 2, or combine it all for a 6. Now the last one, which is even more common, is called a sticky bit. And it took me quite a while to just really understand what this one was about in all my study. The sticky bit simply will prevent a user from deleting a file that they don't own. Now remember, the special user ID was 4, the special group ID was 2, the sticky bit is 1. So let's go ahead and look at this test file again. We still have our user and group special bits in there, designated by the S instead of the execute, right? So when they execute it, they'll become the owner. You can see that the S is related to the execute, so that's the column it's in. Let's go ahead and do a sticky bit now. We're going to use a 1. I said the sticky bit is represented by 1. And we're then going to put the other options back in here. And let's see what it says now. Now you have a T at the end of this. That is a sticky bit, and it means the owner cannot delete this file. Sorry, that is not correct. The owner can delete the file. What this means is, even if any other user has full permissions like these do, like the group has full permissions, right? Read, write, and executable. Everything. It should be able to do everything. But you throw in this T, this sticky bit in here, and then only the owner can delete the file, even though the group has full permissions. That's a way to make sure that the group or the others don't accidentally delete the file, and only the owner itself can delete this file. This is to make sure that a file does not get accidentally deleted if it is a very important file that you are sharing with a larger group. And finally, let me show you one more thing here. We have a work.tar file over there. You can see that. Let's go ahead and look at it. So you can see the permissions there. Now you can do a chmod again, and we're going to do the user and group ID special bit on this file. And we'll see what this changes here. Sorry, let's do a just on that file. You can see it added a capital S now in the group and user. Remember, it was a small s before. So that was a file. Now this is a directory or a tar or a different type of file. It will use a capital S, but the same idea, that when the user does a command with this file, when they untar it, for example, they will become the temporary owner of this file until that is complete. Now we can reverse this by putting a 0. Remember that first section, that first number you put, is all about your sticky bits and your user and group special bits. So we'll put this back the way it was, and we'll look at it, and it is now returned. So that's all about permissions on the Unix and Linux system. I hope you have enjoyed this Linux lesson and tips. Thanks for watching LastHumansTech, and I hope you come back for the next one. We're going to talk about processes.